Because I know where it's right on your friend. Oh, yeah. First week of June. Are you going to mental lunch and graduation? Literally, Emma. It's May 6th. May 6th. What day is it? What day? And I was like, it's a Saturday. It's like there's only 3 of us. I don't go for like 3 of this. And you still here's like don't worry, you got a chance to go there. The 5th year. Are you going to your grad party? Go. 28th. The 28th of June? 28th. No, of May. Well, I got my grad party in August.
So the homework, I think 71 is pretty straightforward once you can understand what this is top minus bottom. With part B, I think it was part B was rectangle. When it says rectangle of height 1, then you're just going to do base times height. So the base is top minus bottom, and then the height is 1. So just basically, it doesn't feel like anything is done to it. It's just times 1. 72 is where we have to create an equation from the circle, from the x squared plus y squared equals 4. So for 72, you're starting off with x squared plus y squared equals 4, which is really a circle with a radius of 2. And if I solve for y, I get 4 minus x squared. So y is equal to plus or minus square root of 4 minus x squared. So that is going to tell you the 2 branches of the circle. So the top portion of the circle is root positive square root. The bottom of the circle is negative square root. And if I subtract them, I get root 4 minus x squared minus a negative root 4 minus x squared. So that's how we get a base of cross section being 2 root 4 minus x squared. And once you have your base, then you find your bound from -2 to 2, and then you use the same information for different formulas. Right. So we have area, square, which is base squared. You have equilateral triangle, which is root 3 over 4 base squared. You have a semicircle, which is pi over 8 base squared, and then you have isosceles triangle with hypotenuse on the base, which is 1/4 base squared. Okay. Okay, so today we're going to start our test review. We're going to try to get through pages 1 and 2 today. And you guys also picked up a solution key, but I want to kind of go through maybe the first few with you and then see if you guys can finish off the rest. At least attempt to try these problems on your own. Okay, but let me point out the back of the page here. These are the formulas that you're responsible for on the test. Right now, I just wanted to give you easy access so that you know where to look if you're having to kind of remind yourself what the rules are. So we have 2 area formulas, basically the same thing. We have top minus bottom and right minus left. We have 2 disk formulas, one for top minus bottom, one for right minus left. You have 2 washer method formulas, one for top minus bottom, one for right minus left. Washer and disk are very similar in the sense that they both involve pi r squared, or just because of the rotation. It's just with the washer method, we got to subtract out little r squared. And then cross section has the most formulas associated with it. But I know it looks daunting with all these formulas, but the nice thing is that pretty much all the formulas is base squared to some extent, except for rectangle. Rectangle is base times height. You know a square is base times base. So it's the other ones, right? 2, the isosceles right triangle with leg on base, hypotenuse with leg on hypotenuse on base, equilateral triangle, and a semicircle. So really, the only thing you have to worry about with these, as long as you know that they're all base squared, is having to memorize the coefficients in front. So everything is either 1/2, 1/4, or 1/8. You just have to worry about the numerator. So leg on base is 1/2. Right triangle hypotenuse is 1/4. Equilateral triangle is √3/4. Maybe it's a way to think about it as equilateral triangle. I think of it as 3 equal side lengths, so that reminds me to put a 3 up there. And then semicircle, we know there's pi involved, so pi/8. So as long as you know base squared, it's just the coefficients you have to adjust to. And then rectangle is just base times height, but you already know that, so you don't have to worry about rememorizing that. Okay. All right, let's go to number 1. All right, given the region enclosed by y equals √x minus 2, that's the graph on the left. You got the phi minus x, that's the linear graph with a negative slope, and the x-axis. And find the area of the region below, right integral notation, as well as numeric approximation rounded to 3 decimal places. So I want us to practice this problem both at the top minus bottom and right minus left, just so that we can get really comfortable going back and forth. Now, on the test, you can choose either method, but I want us to practice both and just be familiar with both methods. Let's explore top minus bottom first. Okay, so if we want to do top minus bottom, do you see anything that we have to adjust to? Just doing area here. So can one area formula do this for us? What do you notice? So if I were to draw a vertical rectangle from one end all the way to the other end, is it all consistent all the way through? No. What's the issue? Okay. We have one region that has a top graph of the square roots. We have another region where the top graph is the line, right? So if I were to draw rectangles, different rectangles in different regions, it's gonna be hitting a different top graph. So what does that mean? Okay, that I need how many area formulas? 2, right? I need 2 top minus bottom because I can't just create, I don't have a consistent top graph all the way through. So I need 2 formulas. Okay. But how is the calculator required besides the volume formula? What else do we need to find? Yeah, the bounds, right? So this is given to us, right? 2 to 5, but is there another bound that we need in between, right? We need to find this intersection here. We will, yeah. So I want us to save enough room where we can do top minus bottom and right minus left, because I want us to practice both on the test. If you see this problem, you can choose either one, but I want to just have us practice both. But let's do top minus bottom first. We know it's going to be 2 equations or 2 formulas. Let's go ahead and find that intersection first. So in your calculator, in your calculator, I'm going to type in both graphs. I have root square root of x minus 2. And then I also have 5 minus x. I like to do zoom 6 just so I can get a standard window, and then I can decide how I want to zoom in if I need to zoom in. Okay, so there's my graph. I can zoom in on that region there. So if I do zoom 1, zoom box. It's gonna pick a starting point. Find that intersection, second trace, option 5. First curve, pick a point close to the intersection, hit enter. Pick a point close to the intersection, hit enter again. And go ahead and write the x and the y value, because the y value is not needed right now, but if we do right minus left, we can just go ahead and have that ready to go. Okay, so let's set up our two integral areas. So integral from 2 to 3.697. I'm under that square root graph. So top of my rectangle is touching the curve. The bottom is touching the y equals 0. Guys, on the test, you don't have to show the -0. I'm just doing it so that I can just follow through the formula. But if you drop that 0, because you already know it's going to disappear, right? I'm not going to pick off any points. Just wanted to show you all the steps that's going into the formula. Okay, top minus bottom here. The top of the big second rectangle is hitting the line, the 5 minus x. And we're going from 3.697 to 5. Okay, and the rest is just calculator work. Okay, if you guys are working ahead, you're welcome to do that. You guys have the keys, so you guys can work ahead if you're already moving on. Okay, let's do the same problem from a right minus left perspective. So I'm just gonna draw the graph here. So if I want to do right minus left, what adjustment is needed before I insert my formula here? Yeah, the equations have to be rewritten, right? These equations that we see are perfect for top minus bottom, but not quite set up for right minus left. So let's rewrite these equations here. I have 5 minus x equals y, or y equals 5 minus x. If I solve for x, I get x equals 5 plus y. Okay, for the curve, we have root x minus 2 equals y. Solve for x, so square both sides. And the bounds we have to adjust as well. The nice thing about right minus left is, do we need more than one area formula? We just need one, right? Because for right minus left, it does feel a little cleaner in the sense that no matter where you draw your rectangle, the right endpoint is always hitting the same graph, and the left endpoint is always hitting the curve. X equals 5 minus. X equals, yeah, you're right. X equals 5 minus y, thanks. Okay, what are the bounds for this volume formula? 0, because that's the lowest y value. What's the highest y value? Yeah, 1.303. We found that order pair from before, so we can reuse that information. Okay, so right minus left is your area formula. Careful though, if we do right minus left, we got to protect the left with a what? Parentheses, yeah, parentheses, thanks. You get the same area, same region. So despite we're choosing two different methods, we should come get result in the same answer. Okay, questions? All right, go ahead and read part B. This is a rotation problem, so you're gonna look at your shaded region, look at your axis, decide is it a disk or is it a washer method. From there, you want to decide is it top minus bottom, is it right minus left? How am I going to find the bounds? Are the bounds in terms of x or bounds in terms of y? If it's a right minus left, how am I going to rewrite my equations so that I can get those ready for my radius? Yeah. Yeah, I did not specify, but yeah, this should be what units squared. Yeah, this area. Yeah, on the test, if I don't specify, then I think that you get to include units, then I won't take off any points. But if I specify units, then but thanks for pointing that out. Okay, read part B, see how far you can get. Nice thing is that it's taking the same shaded region or same graph as from 1. So everything that you need should be available for you already. So you don't have to start from scratch. I can just walk around and see how you guys do with that. And part C is also the same graph, same shaded region. It's just turning into a cross-section problem. And today, we're just gonna try to get through pages 1 and 2. Okay. Right and left. So you see the right and left, considering left and consider next to. Sorry, hold on, hold on. Literally, this is right and left. That's right, that's right. This line minus 1.
Yes, I guess.
It says cross section. Anytime you see the word cross section.
Yeah.
In their page, that's what we know is a cross section problem. You know this watch like this, you see the word horizontal rotation around the lines, and this is just like areas. So the things very placed there.
Yeah. Oh, my God. It was very nice. I can't figure it out. So then you just go on.
This method, so this method is just try this.
Tree word. This one has pie.
That's right, yeah. Anytime it's this for washer, there's a pine.
It's wide squares. Hold on. Okay. Do you know how to do it? If you was from the side, you get. It was 2 minus 1. I'm trying to get rid of it. What happened to your square root? I didn't think equation is 6 minus 2, so square root of x minus 2.
Well, the problem with that square root is not gonna go. We're using the, well, we already did it up here.
That's what I'm saying, yeah, we just directed.
Yeah, we have the equation already. We can use the y square plus 2. We'll use the 5 minus 1. That's our setup for like. You don't want to use. Anytime you want to be right like left, you want to get the active equation. Well, I think this, like 5 minus 1. Or we use this, we should use this one. Y square plus 2. It's not as basic. You can't do this. You can't just take the original equation and replace the next one. That's not the equation that we want to use to rearrange. We have to spend time to rearrange the equation. We want to use the y squared plus 2.
This is just. So.
If it was a horizontal axis illustration, then you become unbound. The axis is always going to tell you which direction to draw your radius.
Wait for time.
Top and bottom your equation would be, you would be using these equations. Right, 'cause these are set up.
I know.
Yeah, yes, yes, this formula, it's just, you have to adjust the variables, and you have to adjust the bank.
So it's nice.
Yeah.
Yeah.
Yeah, really is.
Yeah, that's right. The VDI. Yeah. I'm fine. One thing is can't do that. Statements.
Zero. It's the activation just zero. And then the y is just. Oh, yes.
It's still to the formula, you have a big R squared minus little r squared, then the bounds. Yeah, that's great.
I'm so smart.
Okay, everybody good with part B? Washer method? What's the difference between perpendicular to the y-axis versus parallel to the y?
I guess it's zero was left. So if you right here, it's left.
Yeah.
So it's-
Oh, it is, it is. I just put the, let's put the folder there's just. I have it. I can tell my.
You literally just do this is. Okay. Right. Right.
Oh, doesn't matter. Yeah, that's fine. It's just great.
Is this one gonna be like all this? Okay. I can do this.
I really just want you guys to try these problems on your own, but I want to be able to help answer any questions if you're stuck at any point. Just put it all in the calculator, so. It could be in there. One second. Yeah, so which is like that, that's what we can do is just plug 0, because that's the x value 0, 0 into x. Let's get the point here. It's. Well, they're describing height. It says the height is base. So
That's what. Like, this is the height.
oh, okay, yes, that's perfect. That's what can make it fine. Yeah, let's say that. Okay. Guys, I do want to point out something about your graphing. For number 2, I put the ordered pair of the y-intercept. And I think some students were asking, how can I graph this x-axis and get that intersection with the calculator? You're not going to be able to do that with in terms of the graphing, but this should be an easy point to find because this is the y-intercept of this curve. You know the y-intercept has an x value of 0. So if you just plug 0 in for x, you can get that math 1 to 4, which will give you that y value. So y-intercept, you don't have to use your graphing calculator, just plug 0 in for x, and then you should be able to get the calculator to give you some decimal value, and that will be the y-intercept. So just plug in 0 for the function. But I don't think we needed it. I just wanted to gather all the information in case there was a right minus left problem further down. Okay. 2A is a disk method problem because your dotted line, your axis is right up against the flat surface of your shaded region, so there's no gap, there's no hole, only one radius is needed. That's a little higher than the data region. If you're not sure, you can also graph y equals 2 on your graphing calculator.
Oh, should be like.
That's the, yeah, and then pretend that's the axis and you can just see, oh, it's above the graph. Yeah, and also, just to let you guys know, your axis will never cut through your shaded region. Okay? It's always going to be on the edges or outside of your shaded region. You're never going to have an axis that's going to somehow cut through into your shaded region. Something didn't quite feel right if that's the case. And we'll keep working for another 5 minutes. That's the area. So the area is just top line spot. There's no rotation going. Then you do pi r squared. Yeah.
Okay, thank you.
I realized I forgot to go back to the previous FRQ, part C and D, so I'll do that tomorrow. You guys will remind me. Let's finish that FRQ. All right, so tomorrow we'll just pick up where we left off. So the good thing about today is that you're kind of seeing all the things put together. And we're just gonna continue to build on that tomorrow and next Wednesday. Okay, come get the phones. Oh.
There was a good